Before oceans covered our world, before mountains rose into the sky, before Earth even had a name, there was only chaos. A young star burned at the center of a vast cloud of gas and dust, and somewhere inside this violent cosmic storm, our planet was about to be born. Around 4.6 billion years ago, the young sun was surrounded by a spinning disk of debris, dust, rock, metal. Tiny fragments collided again and again. At first, they were microscopic, but gravity was beginning to build worlds. Thousands of years became millions. Small fragments grew into boulders. Boulders became planetesimals, and planetesimals crashed together with unimaginable force. Piece by piece, collision by collision, the young Earth began to grow. The newborn Earth was nothing like the blue planet we know today. Its surface was an ocean of molten rock. Asteroids struck relentlessly. Volcanoes released enormous clouds of gas. There were no forests, no oceans, no life, only fire. But deep inside the molten planet, something extraordinary was happening. Heavy metals such as iron and nickel sank. Toward the center, lighter rocky material moved. Upward, Earth was separating into layers, a metallic core, a vast mantle, and eventually, a crust. The internal structure of our planet was taking shape. But the young Earth's violent story was far from over. Around 4.5 billion years ago, another young world moved through the inner solar system. Scientists call it the Ia. It may have been roughly the size of Mars, and it was heading toward a catastrophic encounter with Earth. Then, the two worlds collided. The impact released an almost unimaginable amount of energy. Rock vaporized, molten material exploded into space, Earth itself was reshaped. It was one of the most violent moments in our planet's history. The collision did not simply destroy. It created a vast ring of hot debris surrounded the wounded Earth. Under gravity, fragments collided and gathered together, and from the remains of catastrophe, the moon began to form. For millions of years, Earth remained a world of extreme heat, but slowly, the planet began to lose energy into space. The surface cooled, molten rock hardened. Above the cooling surface, a new atmosphere was forming. Volcanoes released vast quantities of water vapor, carbon dioxide and other gases, but this was not air a human could breathe. There was almost no free oxygen. The sky belonged to a completely alien Earth. Then, as Earth continued to cool, water vapor began to condense, clouds thickened across the planet, and rain began to fall. Not for an afternoon, not for a season. Across immense spans of time, water poured onto the young Earth. The age of fire was beginning to meet the age of water. Water gathered in the deepest regions of the young planet, basins filled, shallow seas expanded, and over immense stretches of time, vast oceans emerged. For the first time, liquid water began to transform the face of Earth. But where did all this water come from? Part of the answer may have been locked inside Earth itself, released as vapor from its hot interior. Water-rich asteroids may also have delivered additional material from space. Earth's oceans were likely the result of a complex planetary history. The early solar system was still dangerous. Fragments left behind from planet formation continued to cross Earth's path. Some struck the young planet with tremendous force. Each impact reshaped the surface, excavating enormous scars and altering a world still under construction. Gradually, the chaos began to fade, impacts became less frequent, the crust grew more stable, oceans dominated the surface. Above them, clouds moved across a world that was finally beginning to resemble a planet, but Earth was still lifeless, and its greatest transformation had yet to begin. Far below the surface, the young oceans concealed another world. In total darkness, seawater penetrated cracks in the ocean floor. Deep inside the crust, it was heated by the planet's internal energy. Then, it returned to the ocean. Along parts of the seafloor, hydrothermal systems created extraordinary chemical environments. Hot, mineral-rich fluids interacted with ancient seawater, energy, minerals, complex chemistry. Some scientists investigate environments like these for clues to one of Earth's greatest mysteries: the origin of life. Exactly how life began remains uncertain, but before biology, there was chemistry. Simple molecules interacted, new compounds formed and broke apart across countless environments and immense spans of time. The chemistry of the young Earth grew increasingly complex. Somewhere in that ancient world, the path toward life began. Earth's formation was only the beginning. Over billions of years, its surface continued to change, crust moved, continents assembled and broke apart, the atmosphere evolved, life eventually transformed the planet. The world born from dust and collision became increasingly complex. 4.5 billion years ago, Earth began as dust orbiting a young star. Gravity built it, collisions reshaped it, fire melted it, water transformed it, and time changed it beyond recognition. Today, this ancient world is our home, but every mountain, every ocean, and every stone beneath our feet still carries a fragment of Earth's extraordinary beginning. And perhaps the most remarkable part of Earth's story is that it is still being written.